Bonjour à tout le monde et merci d'assister à cette conférence dans la session Compréhension du monde. Mon nom est Zohair Melki, je suis conseiller au partenariat chez IVADO. À la fin de la présentation, il y aura une période de questions. Vous remarquez dans la fenêtre Discussion interactive qui apparaît à droite de votre écran un onglet clavardage, questions et sondages. Merci d'utiliser l'onglet questions pour poser les vôtres. Je vous conseille de rédiger vos questions en cours de la présentation et ne pas les laisser jusqu'à la fin. Alors, sans plus tarder, je vais introduire mes deux conférenciers et ça va être en anglais. I'm pleased to welcome Crystal Liu and Nick Ponto from IBM. The presentation is titled Multi-Plant Production Optimization. Crystal is a senior analytics and AI manager with IBM. She focuses on helping organizations build digital transformative capabilities and delivering AI solutions to empower businesses in making data-driven decisions. Crystal has over 10 years of experience in the mining and energy sector. She holds a BA in mineral engineering and a master's degree in business analytics. Nick is an associate partner within IBM's Natural Resources Solutions Center. He spent 20 years of his career in the development of and operation of mining assets. His areas of expertise include application of analytics solution to mining space, life cycle mine planning, mine operation and maintenance, capital project, and cost modeling. Nick, Crystal, thank you again for being with us. The floor is now yours.
Thank you very much. Excited to be here and happy to share with our solution with the folks here at IVADO. I am really looking forward to being able to demonstrate, the value that this solution can bring. We were hoping originally to have one of our associates that actually worked at Suncor to share the solution because they deal with this solution on a day-to-day basis. But I'm going to do my best to bring the business feel and actually how the user experience is the multi-plant production optimization solution.
Hi, Crystal Liu here. Really nice to be with you here all today. I was the delivery lead as well as the data scientist on this project, so hopefully I can help answer any questions today.
Excellent. Thanks, Crystal. And I will get going now. So as noted just at the front, this solution is actually been implemented at Suncor Energy. For many of you may be familiar, but Suncor has a daily production of over 900,000 barrels per day of production and an upgrading capacity of just over 500,000 barrels of production and over 1,700 retail sites. So Suncor itself is a large integrated oil and gas company. And really where things get interesting is you can see on the visual here at the top left, you start with an oil sands deposit and coming out the back end, ultimately what you're going to have is fuel, whether it be for your vehicle, for an airplane, or for some other purpose where you would make use of hydrocarbons. So if we look at a high level process flow here, you've got your oil sands deposit, then produce and manufacture that bitumen, you add diluent to that product, which is then sent to an upgrader, and then either to a simple refinery or a high conversion refinery. This is a really simplistic view of what the process flow is going to look like. Where things get exciting is when you actually really drill down to what is going on. So looking at Suncor, the way their operations work, they have over 30 plants that are all interconnected that provide over 130,000 measurements and over 1,000 key metrics with over 80,000 sensor readings. So you can start to get a feel to the complexity of all the information that is coming at the operators at Suncor. And really when we look at this, how do we integrate the world of data science with the physical complexities of industrial production? And one of the challenges that Suncor saw here is at Suncor, it was the responsibility of the site-wide lead to manage the production and throughput of these 35 plus disparate systems, and ultimately to either maximize output or to manage inventories of various products. And you can really start to see the complexities that the user had to really make decisions with on a day-to-day basis. An experienced user would start to see, okay, I understand first level, second level, third level decision making, and they would be able to make some strong recommendations. But the challenge is that fourth, fifth, sixth layer decision making is really complex. And when we see the amount of data that is actually coming at the user, more often than not, they're only able to make base decisions and not really understanding what an optimized solution would look like. So Crystal and her team worked with Suncor to say, okay, well, how can we improve that decision making? How can we optimize across all silos? How can we flag upsets so that we can respond in a timely fashion? And then also really key to this is, how can we action opportunities in real time? So go to the next page here. This is really looking at, one of the three solutions that are included. The first one, which is process upset flagging. We saw in the previous pages there, there's way too many processes to track at once. How can I be notified if a key inventory level is dropping? I've got these 30 plus plants. How do I know what is actually important? How do I know if something's going to fail before it happens? How can I be proactive? And how can I have access to information when I'm on the move? Typically information is provided through SCADA systems and visualizations, but you need to be sitting in a control room, not necessarily out in the field and on the go. So really the solution that was built here was to provide a real-time AI-driven early warning notification for user-defined upsets. And I'll take you through an example of what this looks like. On the left-hand side here, you can see there's a quality measure. Across on the horizontal axis here, this is the quality threshold. And on the bottom, we've just got a time scale. So in operation, you can see that the quality is in, well above the quality threshold. Things are going well. As an operator, I think, things are going well. I'm not concerned, no changes. But really where the value is that the machine learning models can provide early warning for potential high value upset. So if no action was taken, the machine learning model identified that actually the quality would go into a negative quality below the threshold and actually potentially go into an upset condition. So as a result of this early warning, we're actually able to then optimize and change the production throughput to avoid that upset condition. And really it's creating that preventative opportunity that really is going to provide the value and avoid those upset conditions. And really avoiding upset conditions is the best way you can avoid, to increase your production throughput is obviously by staying operating. So this kind of segues nice into, okay, well, we've avoided an upset condition, but in order to do that, I need to generate a new scenario because I need to change parameters. Am I targeting maximizing my production? How do I reset my production in the event that I did have an upset? Or how do I compare the outcomes of various production strategies? Whether that's maximizing throughput, if it's managing expensive inputs to the process. So ultimately, the solution that complemented the upset conditions was an end-to-end optimization model integrating machine learning with real-time material balance, generating new production plans within minutes. When I look at this page here, the way I like to look at the layers of the models is really kind of starting with the end in mind. So if you look on the right-hand side where we've got our goals, really what you're defining within the model, and this is key to it, is what your objective function is. There's various reasons that you may change your objective function, and the flexibility in the tool allows the user to do that. Have I been asked to maximize production? Potentially there's a market spike, and if I can move more product to the market and expedite that, there may be significant value in that. Or maybe the expensive inputs that I'm using in the process, is there a limit or a restriction in terms of their availability, or I'm just looking at how I can maximize margin. So really it's the flexibility to modify your objective function there. And then as we move across, the ability to modify your constraints to avoid process upset, the ability to potentially integrate and move those maintenance windows, how your tankage and your flows are monitored. And then on the left-hand side, looking at different predictive models, whether it be standard linear regression, decision tree, Mars, however you actually want to test the model to look at various solutions, there's a significant level of flexibility within the model and the ability of the user to move through this in an efficient fashion. So when we look at generating the production plans, I think one of the key things that I take away is, as an operator, I am going to do what I know. I'm going to go to the same bag of tricks. I'm going to kind of do things the same way. I can only learn to what I'm exposed to and then what insights I can generate. And this is where the differentiation comes when you actually have a tool that provides guidance on that decision-making basis. So if we can eliminate some of that bias and provide alternatives, there's a huge benefit to Suncor. And I think in talking to a number of the users, the feedback was that they were able to actually see results and understand that there were some decisions that wouldn't have been made by themselves, but they understood why the tool was making those recommendations. And it was actually the more senior operators that were able to provide that insight. For the more junior operators, they didn't necessarily see, those connections, but that really actually provided support to the IBM team in Suncor that we're moving away from the art of the possible to actually this is something that can be implemented, and they're seeing why value will be generated here. The third solution that was prepared for Suncor here is opportunity awareness. As an operator, I need to investigate way too many data sources to see if there's an opportunity for improvement. How do I understand if I make a change, what is that butterfly effect or cascading effect in terms of, what impact that will make, and how can I be aware that I don't miss opportunities? I am busy. I'm looking at screens nonstop. I don't have time to actually look at opportunities and sensitivities unless we bring multiple more people in to start testing these opportunities. What if I've been asked to maximize utilization of the key assets? Well, how can I change my modeling? Again, it comes down to having the time and ability to take action here. And one of the other key things that when I look at this is, okay, there's an action that can be taken, but how can I be confident that I have enough information to make that decision? And once that decision has been made, how can I ensure that my supervisor and the appropriate records are in place so we know why that decision was made? So by applying machine learning and analytics to real-time data, ultimately we're able to bring high-value opportunities to the forefront as they presented themselves. So taking a look at what this solution would look like in a user experience, on the left-hand side, this is volume and production rate. On the bottom is, again, a time scale. This light blue line here is your unused capacity in the plant. And then this upper line is plant production. So in looking at this lower line, you can see that our unused capacity, we actually started to see an increase in our unused capacity. So what the model does is it identifies that potential unused capacity and see if there's an opportunity to improve throughput downstream such that you would increase your plant load. So you've identified your opportunity, and then there is a request to action that opportunity, which we'll show on the next page here. And then as that opportunity is actioned to increase plant load, you see that there is an increased throughput of the plant, and we actually then see that decrease in unused capacity. Very simply put, you could say, well, you know what, an operator that could figure this out themselves, sometimes yes, but what it comes down to is you've actually got data that supports these decisions and provides these recommendations. Ultimately, it is the user who is responsible for making this recommendation. We're just providing the decision support tool to enable that recommendation. And I think the level of transparency here is where you see a lot of the value, and the user actually being able to embrace the tool because they can understand and see what the planned future impact is going to be. Within the solution, it can be displayed on a mobile device such as a phone or a tablet or on computer screen. And I think really it comes down to the transparency of, we've got the site-wide lead position who is ultimately responsible for these recommendations, but their leader or some other senior executive within Suncor has the ability to actually see what is going on through these plants, which is really the heart of Suncor operations is all the connection between these facilities. So it provides a great layer of transparency. And then this is really just showing what an example of what that opportunity looked like, that there was a production gap of 495 barrels. So once that's been identified, there was a request made to increase throughput. There was positive feedback on that request, and ultimately there was a call to the supervisor to action and to move forward with that recommendation. Again, it's creating recommendations, transparency, and traceability ultimately to go back and understand why decisions and recommendations have been made. So you're able to leverage the experience of the operators through this tool, and they've incorporated their thoughts into the development of it. But then you've also been able to add a second layer through the machine learning and advanced analytics in terms of providing insights that they may be challenged to come up with unless given enough time and data. So in closing, I'll maybe just kind of look at the middle of the page here. The ability to generate optimization solutions in about 5 minutes. We're looking at connecting 30+ plants. It's extremely complex. So being able to do that in near real time has been a huge benefit for Suncor. The other piece, just in terms of lead time for process upset conditions, 30 minutes, that's enough time, as you can see on the left, to look at various scenarios and optimizations. And through experience, we're seeing over an 82% accuracy for the ML models to identify those upset conditions. At the top here, and this was from an article about maybe a year ago here, that they saw the value in the order of millions of dollars per year. There are some real savings. Again, it's a bit of Suncor's secret sauce on what those savings actually are. But we definitely have seen improved value through this solution, and believe that it's applicable obviously for Suncor, and similar type solutions can be applied across various industries. Thank you.
Thank
Are there
you.
any questions? Yeah.
Thank you, Nick. Thank you, Crystal, for this presentation. It was really interesting. Now it's a question period. I will see if there is any. A first question from me. Is this applicable in other sectors? You presented the case of Suncor. Does it have specificities that make it more suitable for this type of application?
You want to touch on that one, Crystal? And I've got my thoughts.
Sure. Yeah, so the framework, the predictive and optimization framework and the different solutions has been modeled in a way that is applicable across many, we would call heavy industries. So we have adapted the tool and to understand its application in a factory type setting, a steelmaking type setting. So all of those have seen kind of success in using this kind of framework of optimization to provide augmented decision making.
And within IBM, we've actually deployed this in a couple of other applications. One would be an integrated operations, looking for how we actually move product from a mine operation to a port facility, then actually a more detailed solution where we've actually implemented in a port operation. So IBM has a number of solutions where we have variations of this type of application. And again, we've been primarily focused on the heavy industries here, but yeah, it's, I believe, pretty widely applicable. If we don't have any other questions, or if we're waiting for a minute here, Crystal, was there anything else just that you thought that I maybe didn't touch on from your experience and what you heard while building the solution that you could maybe share?
Yeah, I can talk about kind of the context or the origin of the opportunity a bit, because for any industry, I think optimization is not anything new. We have been doing it for years, and for Suncor, there's teams for it. But I think where this tool really came in handy, or what really kicked it off, is how to optimize across the board. And it's really to augment. It's not to tell the operator you need to do this now, but it's to take the tedious work out. Like we were talking about opportunities or optimization, most of the time now they have to do the research themselves, plugging into an Excel, and then run it several times, go through it with several teams, and then make a decision. Now we want to take all the work before out of the way, so that we're already doing the information data ingest within the model, and then doing most of the calculations. And the remaining that's left for the users is to take the different recommendations and talk amongst themselves and coordinate with the different teams. So the time is actually spent on deciding what is the best strategy and direction, instead of developing the different options and directions. So hopefully that kind of also captures, why we broke it down into 3 different solutions, is to give them the amount of time to coordinate and give them the right information to augment their decision making.
Oh, I think we got you're on mute.
Thank you, Crystal. Thank you, Nick, for your great presentation and your response. Merci beaucoup à tout le monde d'avoir assisté à cette présentation. Je vous informe qu'il y aura une session de réseautage juste après. Donc, je vous invite à aller réseauter et profiter. Merci, merci Nick. Merci Crystal. Au revoir.
Thank you.
Thank you.